Back in 1876, there was this microscopic fungus that it nearly wiped the entire global coffee supply completely off
Oh,
the road.
absolutely. It was devastating.
Yeah, it just chewed right through these massive plantations, ruined economies, and basically brought this exploding global industry to its knees.
Right.
So if you were drinking a cup of coffee right now, that dark liquid in your mug isn't just like a simple morning pick-me-up. It's actually the direct result of a desperate, centuries-old botanical war.
That's a great way to put it.
Welcome to today's deep dive. We are looking at this really fascinating botanical blueprint we've got. It details the profiles and the characteristics of the main coffee species grown in Indonesia. And our mission today is to decode the exact science and history behind your morning brew.
And yeah, it really is a remarkable document to go through because, when we talk about coffee, we're actually talking about this genus of evergreen shrubs called Coffea,
Right.
which belongs to a much larger botanical family called Rubiaceae. And what's wild is there are around 100 different species within the coffee genus.
100 different plants.
100, literally.
Wow. Yet, out of all those 100 species, this massive multi-billion-dollar coffee industry essentially just relies on 3.
Yeah, just 3.
It's like 3 hardworking botanical cousins carrying the entire weight of keeping the human race awake.
Basically, yeah. Arabica, Robusta, and Liberica. And understanding these 3 specific plants, like how they function at a cellular level, how they interact with their environments, it's totally crucial.
Because it shows you what's really going on.
Exactly. It gives you this entirely new appreciation for the agricultural battles happening behind the scenes. I mean, we really cannot comprehend the modern coffee industry without understanding the biological constraints of these 3 survivors.
Right. And to understand that survival, we kind of have to start with the catastrophe, right? The threat that almost ended the whole story before it really got going.
The 1876 plague.
Yeah. So let's look at Indonesia in the 17th century. The Dutch colonial government, they bring the very first coffee plants all the way from Yemen over to Indonesia.
And that first coffee was Arabica.
Right, Arabica. And for a long time, the system just hums along. They're exporting beans. The demand in Europe is skyrocketing. And then in 1876, this invisible enemy arrives.
The pathogen known as Himalaya vastatrix,
Sure.
or, commonly called coffee leaf rust.
Leaf rust. I mean, we hear the term rust and you just think of like an old car or something.
Right.
But this is a living, really aggressive organism. So how does a fungus actually take down an entire agricultural empire?
Well, it basically suffocates the plant. The spores of this fungus, they travel on the wind or even just through rain splash.
Oh, wow. Just from the rain.
Yeah. They land on the coffee plant and they specifically target the underside of the leaves. And then the fungus infiltrates the plant's stomata.
And those are the little breathing holes, right?
Exactly. They're the microscopic pores the leaf uses to breathe and, exchange gases. Once it's inside, the fungus just feeds on the plant's nutrients.
Which causes those weird spots.
Right. It causes these very distinct powdery orange-yellow spots on the leaves. And as the infection spreads, the leaf completely loses its ability to perform photosynthesis.
Because the fungus is like literally blocking the solar panels.
Precisely. And without photosynthesis, the plant starves. It actually prematurely drops all its leaves to try and save energy.
Oh, as a defense mechanism.
Right. But obviously, a plant without leaves cannot produce fruit. So the coffee cherries just wither, and eventually the entire shrub dies.
Okay, let's unpack this. Does this mean that the modern coffee industry we know today is essentially built on the ashes of a 19th century botanical plague?
In many ways, yes. If we connect this to the bigger picture, you have to realize the sheer panic this caused at the time.
I can imagine.
Yeah, I mean, before 1876, farmers were primarily just growing what tasted the best. But when leaf rust swept through and just burned down the livelihoods of thousands of people, taste had to take a back seat.
They just needed something that wouldn't die.
Exactly.
Yeah.
They could no longer afford the luxury of just growing the most delicious bean. They had to scramble. They had to find plant species within that coffee genus that were biologically armored enough to survive.
Which brings us to the original victim, right? The one that tasted the best. Let's look closely at Arabica, or Coffea arabica.
Yes.
Because even though it was decimated by that fungus, I mean, we still grow it today,
Yeah.
it remains the undisputed gold standard for your morning cup.
It really does. Originating from the highlands of Ethiopia, Arabica is what most people are drinking when they go to, like, a nice specialty cafe.
Right. And the source material actually outlines its physical profile. It grows to about 3 to 5 meters tall.
Mm-hmm.
It's got these horizontal branches, dark, glossy green leaves. And when it blooms, it produces these highly fragrant, tiny, star-shaped white flowers.
Which eventually give way to those dark red cherries, usually holding 2 coffee beans each.
But the reason Arabica tastes so incredible, that smooth, fragrant, complex flavor, it's intrinsically tied to its vulnerability, isn't it?
It is.
Because it requires these very high altitudes, strictly between 1,000 to 2,000 meters above sea level, and cool temperatures like 15 to 26 degrees Celsius. Why is it so incredibly picky?
Well, it comes down to metabolism.
Okay.
At those high altitudes with the cooler temperatures, the Arabica plant just grows much slower.
Like it's in no rush.
Right. And that delayed maturation process forces the plant to spend way more time developing complex sugars and lipids inside the coffee cherry itself.
Oh, I see.
Yeah. And those locked-in sugars are exactly what you eventually experience as those delicate floral or fruity notes when you get a premium roast.
So the cold weather is essentially like marinating the bean.
That's a good way to look at it, yeah.
But the processing is also incredibly demanding, isn't it? The sources note Arabica typically requires what's called the wet method.
What makes that so much more complex than just, picking the fruit and drying it out in the sun?
Well, when you pick a coffee cherry, the bean inside is actually covered by this sticky, sugary layer called mucilage.
Okay.
And if you just leave Arabica out to dry in the sun, those complex sugars we just talked about, they can easily ferment unpredictably and totally ruin the flavor.
Oh, so you have to get that sticky stuff off.
Exactly. So the wet method involves mechanically pulping the cherry first to remove the outer skin. Then you submerge the beans in these really large water tanks.
Just soaking them.
Yeah. And natural enzymes in the water ferment and eat away that sticky mucilage layer over several days. But it has to be in a highly controlled environment.
Wow.
And only after all that are they washed and dried.
So it requires expensive machinery, vast amounts of clean water, precise timing. It really feels like Arabica is the artisanal baker of the botanical world.
Oh, definitely.
It produces the absolute most delicate, exquisite product on Earth, but completely refuses to work if the thermostat is off by even 2 degrees.
And demands top-tier equipment in the kitchen to boot.
A very demanding baker, yes. And unfortunately, a baker with a severely compromised immune system.
Right, because of the rest.
Yeah. Because Arabica's ultimate weakness is that it still has very little natural defense against that Himalaya vastatrix fungus.
Yeah.
Down in the lower, warmer lands where the fungus thrives, Arabica was just wiped off the map.
So the Dutch farmers were just staring at empty fields in the lowlands.
Yeah.
Arabica couldn't survive there anymore. They needed, biological tank. They needed a survivor, and they actually found it in the Congo, right, in 1898.
Yes. Coffee canephora, universally known as Robusta.
Robusta. And it was brought to Indonesia around 1900 to replace all those dead Arabica crops. And physically, it is just a completely different beast.
Completely different. Robusta thrives exactly where Arabica surrenders.
Wow.
It loves the lowlands. It grows really comfortably from 400 to 800 meters above sea level. And it actually prefers the heat, thriving in temperatures between 21 and 30 degrees Celsius.
But most importantly for those desperate farmers, Robusta practically ignores the leaf rust pathogen. The fungus lands on the leaf, but it fails to take hold and destroy the plant.
What's fascinating here is how it actually does that.
Here's where it gets really interesting. Yeah. What is Robusta's secret armor? How does it survive?
A chemical warfare.
Chemical warfare.
Seriously, think about it. We value coffee for the caffeine, right? The stimulant that wakes us up.
Sure.
But to the coffee plant, caffeine isn't a fun stimulant. It is a highly toxic alkaloid.
Wait, what?
Yeah. It functions as a powerful natural pesticide and fungicide. And Robusta produces significantly higher levels of caffeine than Arabica does.
Wait. So the caffeine is literally the plant's immune system.
Exactly that. When a pest tries to bite into a Robusta leaf or a fungal spore tries to infiltrate its stomata, the high concentration caffeine essentially poisons the attacker.
That is wild.
It paralyzes the nervous systems of insects and literally disrupts the cellular structure of fungi. Robusta survives because it is constantly pumping out toxic chemical defenses.
That just blows my mind. The very chemical we rely on to get through, A boring morning meeting is the exact same chemical the plant uses to fry the nervous system of an attacking bug.
Exactly.
But nature always demands a trade-off, right? So what does all that chemical warfare do to the actual taste of the bean?
Well, it makes it harsh. You see, caffeine is inherently very bitter.
Ah, okay.
And because Robusta is loaded with it, and because it grows faster in warmer climates so it doesn't slowly develop those complex sugars, the resulting cup of coffee is noticeably more bitter.
Right.
It's slightly more acidic, and it really lacks the aromatic subtlety of Arabica. In the specialty coffee world, it is frequently labeled as a quote-unquote second-class taste.
You know, I have to push back on that second-class label a bit.
Oh.
Yeah, because the source material really highlights the yield. A Robusta plantation produces anywhere from 900 to 2,000 kilograms of coffee per hectare every single year.
It is highly productive.
Yeah, it flowers faster, it produces way more fruit.
Yeah.
If Arabica is this fragile sports car that requires perfect weather, Robusta's chemical defenses make it like a rugged, unstoppable pickup truck.
I like that.
It might be a bitter, bumpy ride, but it is definitely doing the heavy lifting.
And the global market really reflects that. Today, Robusta accounts for over 90% of Indonesia's coffee plantations.
90%?
Yeah, it forms the backbone of instant coffees, espresso blends, and the commercial-grade coffee you'd find in, diners or grocery stores.
Right.
It provides the reliable volume that actually prevents coffee from becoming this rare, hyper-expensive luxury reserved only for the wealthy.
Okay, so Arabica dominates the high altitudes with flavor, and Robusta dominates the mid to lowlands with chemical warfare. But what happens in the absolute lowest altitudes, like the areas with really poor soil where it's incredibly hot, swampy, challenging places where even Robusta's chemical firewall starts to fail?
Well, that is where we meet the third cousin, the rarest of the three main commercial species, Coffea liberica.
Liberica, originating in Angola and then introduced to Indonesia much later, right around 1965. And the sources call this plant the giant of the lowlands.
And it definitely earns that title. It grows significantly larger than Arabica or Robusta, and it possesses a real superpower. Liberica has the absolute highest resistance to leaf rust out of all three species.
Really? Better than Robusta?
Better than Robusta. It thrives in harsh, hot, nutrient-poor environments where the other two would just wither and die immediately.
Wow. So this plant is basically a botanical bunker. It sounds like the ultimate solution to all the farmers' problems.
Well, this raises an important question. If Liberica is mathematically the most resilient, indestructible species, why isn't it the most planted? Why aren't 90% of global plantations switching to Liberica right now?
Right, because it fails the commercial test. The blueprint outlines a couple of major flaws. First, the plant produces these massive cherries, but the fruit size on a single tree is completely uneven.
Yeah, totally erratic. You will have a huge cherry growing right next to a tiny one. And if you're trying to use mechanical sorters and processing equipment that are designed for uniformity, Liberica just jams up the whole system.
It does. But the true barrier to mass commercialization is actually the yield ratio. When a farmer harvests Arabica or Robusta, a decent percentage of the cherry's weight is the actual bean inside.
The part we want.
Right. With Liberica, the yield is a shockingly low 12%.
Wait, only 12% of it you pick is actually the product you want to sell?
Correct. And that low yield is tied directly to its survival mechanism.
Oh, really?
Yeah. We talked about Robusta using chemical defenses, right? Well, Liberica uses physical armor. The cherries have an incredibly thick, tough, leathery exocarp that's the outer skin.
Okay.
And a very dense layer of pulp. That thick armor is highly effective at stopping insects from drilling in, and it prevents fungal spores from taking root.
Oh, I see.
But that physical protection takes up so much space and energy that the actual bean inside remains relatively small. So a farmer spends all day harvesting a literal ton of Liberica cherries, and 88% of the physical weight they haul back is just fibrous armor and waste.
Exactly. Economics just don't make sense. Farmers are hesitant to mass plant it because the return on investment is terrible.
It's an incredibly inefficient delivery mechanism for a coffee bean.
Highly inefficient.
So what does this all mean? We have this giant indestructible plant that fails the commercial test just because its beans are too sparse. But maybe we're judging the plant by the wrong metric entirely.
Oh, where are you going with this?
Because there's this really cool ethnobotanical fact hidden in the source material that completely shifts the perspective.
Ah, you are talking about the leaves.
The leaves. I mean, for centuries, human beings have obsessed over extracting the seed, the little pit from the center of the cherry.
Right.
But with Liberica, the plant grows this massive canopy of huge leaves. And local communities figured out that you can actually harvest the leaves themselves, dry them, and steep them into a hot beverage.
Yeah, a brew that acts much more like a tea, actually containing a lower, smoother caffeine content than the roasted beans.
Exactly. We look at this giant plant and complain that it doesn't give us enough seeds, while completely ignoring the fact that its giant leaves can be utilized perfectly well.
We're missing the point.
We're judging a fish by its ability to climb a tree. We want Liberica to act like Robusta, but it's just an entirely different resource.
It really highlights a kind of tunnel vision in the agricultural industry.
Yeah.
By restricting our definition of coffee strictly to the roasted bean, we completely ignore a vastly more sustainable yield from a plant that requires almost zero pampering or chemical intervention to survive.
Wow. So to bring this all together for you listening the next time you take a sip of your coffee, I want you to look at the liquid in your cup. It is quite literally a masterpiece of biological survival.
It really is.
You might be tasting the slow-matured, cold-weather sugars of Arabica. You might be feeling the jolt of Robusta's intense chemical warfare system. Or, if you're very lucky, you're tasting the heavily armored resilience of Liberica.
And knowing the mechanisms, the stomata, the fermentation process, the caffeine toxicity, it really demystifies the agricultural reality.
Yeah.
It gives you a profound respect for the farmers who have to constantly balance flavor against biology, trying to coax this incredibly demanding genus of plants out of the earth, especially when you consider the current trajectory of our climate.
Which brings us to a final thought I really want you to mull over today. Our sources make it abundantly clear. Arabica strictly requires cool, high-altitude climates, that very narrow band of 15 to 26 degrees Celsius.
Right.
But we know global temperatures are actively rising.
They are. The climate bands are physically shifting. As the lowlands get hotter and hotter, that ideal cool weather zone is moving further up the mountains.
The coffee belt is essentially being squeezed. Farmers are having to plant Arabica higher and higher just to chase that cold air. But eventually, you reach the peak. There is literally no more mountain left to climb. If these warming trends continue, the fragile, complex Arabica could be pushed right off the top of the mountains and disappear from commercial viability altogether.
It's a scary thought. The gold standard of coffee could go extinct outside of highly controlled greenhouses.
And if it does, what happens to our entire coffee culture? Do we rely entirely on the bitter, rugged survival of Robusta? Or, as the climate pushes our agricultural zones into these hotter, harsher realities, will we be forced into another massive pivot, just like they were in 1876?
History repeating itself.
Exactly. Only this time, instead of grinding beans, maybe the future of your morning routine is steeping the resilient leaves of the giant Liberica plant. Think about that biology during your next coffee break.